to ensure that you are doing it correctly. All right, here we go. So we are on this side. Please find this handout. If you are not in live instruction, you have direct, if you have indirect instruction. So here's the first thing I want you to realize that I think there may be a little misconception about, and that is just because it says to divide by this quantity doesn't mean it's a factor. So if that term factor, if it's a factor of a polynomial, it means the remainder is going to be 0. If this was a factor, it means what would be one of the x-intercepts? 5. Okay, got it? So that's one of the misconceptions, is just because I see this doesn't mean that it's a factor. So it says when we take this polynomial and we divide it by 5, we get a remainder of 4. Okay, gotcha. So I'm going to take this, I'm going to set it equal to 0, and I'm going to solve. That would give me x equals 5. And I'm going to choose to do synthetic division, mama method. If you want to do long division, that's okay. Make sure everything's accountable, and I am selecting the correct polynomial. 3 is the leading coefficient. -2 is for x the squared, x the first is k, and -3. Now here's another misconception. I think if I just gave you time, a lot of people would put 0. Again, we just automatically think factor and put a 0. It says the remainder is 4. We want to solve with the k value. I'm dropping down the first term, and then I'm going to multiply, add, remember mama method. Multiply to get 15, add to get 13. Multiply, oh, you guys are going to help me here. 5 carry the 1. Is that 65? 65. Carrying down is 65 plus k. Now I'm going to take 5 times 65 plus k. And when I add down, I'm going to get 4. So I have -3 plus 5 times 65 plus k equals 4. I'm going to come off to the side here. 65 times 5 is 325. If you see me make a mistake, an algebraic mistake, please let me know. Okay, I'm going to combine these to get 322. I'm going to subtract the 322 to the opposite side to get -318. Are you guys agreeing with me so far? And when I divide by 5, I'm going to have -318 divided by 5. All right, so the next part of this is for part B. Says, by Mr. Welch, it says if x plus 3 is a factor. If it is a factor, show your work. And we want to solve for k again. So we're going to come back to this, and if it's a factor, I set this equal to 0. I have a -3, and if it's a factor, I know that the remainder is going to be 0. So just like I did above, I have 3, -2, k, and -3. I'm dropping down, and then I'm multiplying, adding together, multiplying, adding together, so k plus 33, multiplying, -3 times k plus 33, and I know it has to equal 0. So off to the side here, I'm going to do my work. I have -3 plus -3 times k plus 33 equals 0. I'm going to distribute the -3 to both the k and to the 33. When I add here together, I end up with a -102. -3k equals +102 when I add the 102 to the opposite side. And now I divide by -3. Now let's see if that goes in. Let's just check and see. So 3 goes into 10 3 times with a remainder of 1. 3 goes into 12 4 times. So what does that mean for k? A positive divided by a negative, it's going to be a -34. -34. That would be the k value. That would be the k value. The function g of x has a 0 at -4, and it has a multiplicity of 1. Rewrite g of x in completely factored form. So if this is a 0, we can write the factored form of x plus 4. X plus 4. All right, so completely factored form. This is a factor of this. So what I want to do is I want to take the function, the polynomial function g of x, and I want to divide it by x plus 4. That's what I'm going to do, and I'm going to choose to use synthetic division. You could use long division as well. So I'm putting a -4 out front because I set this equal to 0 in my mind, and I solved. And then I'm going back to g of x. The leading coefficient is 2. There's x cubed, x to the second, x to the first, and x to 0. Now, if this is a factor, it is because there's a 0 at -4. I know the remainder is going to be 0. Why am I doing this? Because what I have for remainder will help me write this in factored form, hopefully. I'm dropping down the 2, and I'm multiplying. I'm adding, and I'm multiplying. Well, the difference is a positive 15, and I multiplied. Okay, so this is what I have. I use synthetic division. I knew I was going to get 0 if it's an x-intercept or a 0. But what do I do with this portion? So we go backwards. Remember, this has 0 x's. This has 1 x. This has 2 x's. And this is what I'm going to factor. So let's do a little timed factoring right now. I'm going to give you a head start, and let's see, can you have this factored in 15 seconds? Can you have this quadratic equation factored for me in 15 seconds? Ready? Get set and begin. What multiplies to give us 30 and combines to give us a negative 13? That'd be 15 and 2 with the 15 being negative. Okay, so I'm dropping down the A and the C, and then in the middle I'm putting down the 2 terms I have. I'm going to put 2 down first, but you can put either one. So I'm going to write down 2x and negative 15x. The 2 has to be positive, the 15 has to be negative. You could put down 15 first, that's okay too. Alright, so let's factor this. Out of these two, I can factor out, and we could get the same answer at the end if you put a negative 15 first. But I can factor out a 2x, and I'd be left with x plus 1. What times x is a negative 15x? That would be a negative, ooh, did I write something down wrong? Right. What'd you say? Hold on one second here. What did I do something wrong up here? These two, I put a positive what where? I put a positive 30 at the top, that's right. Oh, okay, I put a positive, okay, I got you here. Oh, yes, thank you. So it can't be that combination is what you're telling me, right? Thank you. This is a negative. I chose the wrong combination. Thank you, kiddos. Sorry for those that are rewatching this. So this is going to be a negative 3 and a negative 10, correct? Okay, thank you, thank you, thank you. If you're rewatching this, I chose the wrong combination. Yes, 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 they combined to give us a negative 13, but they did not multiply to give us a positive 30. So I'm going to go back to this portion, and I'm going to change these two. So I have a 2 out front. I'm going to come off to the, well, you know what? I can probably just fold this up and give myself a little more space. I have a 2 out front, I have a 15 in back, and now these should have been my selected numbers. Thank you to those that are with me live that found my mistake. So I can factor out an x, and I'm left with 2x minus 3, 2x minus 3. What times 2x gives you a negative 10, a negative 10x would be a negative 5, and that times negative 3 gives you a positive 15. Bless you. Okay, so they both contain 2x minus 3. In front of the first parenthesis, x. In front of the second is a negative 5. We're asked to rewrite this in completely factored form. So I'm going to be lazy. I'm going to leave those right here. This is g of x. And what is the other thing that I'm forgetting right now? The x plus 4. X plus 4. If I asked you to take time to distribute all of this out, you're going to FOIL this and distribute this, and then you combine like terms, you would end up with g of x. Thank you once again for those who found my initial mistake. All right, this is really interesting. Okay, you ready? I'm just going to make up a random, I'm going to make up a random polynomial. You ready? A random polynomial here, so everybody can see this. And so here we go. You ready? I want right now, let me put this on pause. If we are all looking at the screen here, I was going to do a little activity. We're all looking at the screen right now, and I'm telling you that this is a cubic polynomial, and we want to come up with, without knowing exactly where the intervals are, we want to be able to approximate a range on the x-axis where we think they would cross. Why do you think it's possible for me to say I believe between 1, 2, 3, 4, I believe between negative 4 and negative 6 there's going to be a 0. Why do you believe that is? You're going to say that in words in the next part. So why do you believe between negative 4 and negative 6 in the x-axis there will be a 0? If you know these are points on a cubic polynomial. Why? Because if we're starting to connect these points, it has to go through the graph to get from this point down to this point. Do you guys agree? Okay, mathematically, what can you tell me about the outputs or the y values in this range and the y values in this range? If I told you all the very small little data points in between here, what would happen between the outputs up above and the outputs down below? They'd be positive and negative. Would you agree? When we have outputs that switch from a positive to a negative, guess what's just happened? We just crossed the x-axis, which means what just occurred? An intersection on the x-axis. Come down here. Down here, we are going to make a little line here. They want us to make a number line, so just make just one x-axis. We're going to put this as the x-axis. And now that we know, if I flip back up here, now that we know what our x-intercepts are, so if I set every single one of these equal to 0, I'd have one x-intercept. We already know that at -4. If I set this equal to 0, I'd have another x-intercept at +5. If I set this equal to 0, I'd add 3 to the opposite side and then divide by 2, which is 3/2. 3/2 is the same as 1.5. So let's come back over here. Let's go here's 0, and then we have 1, 2, 3, 4. So go to 4. 1, 2, 3, 4, 5. Here's 5, and here's 1.5. Without seeing this graph, how do I know where are things positive and where are things negative? I think there's multiple ways you can do this. I truly believe without having to do the way that the author of this document created this, I think there's more than one way. Who knows right now, based on looking at the equation of g of x, this is g of x. Who knows, looking at g of x, what would be the y values over here? Positive. Turn to your group. How the heck did Fabian come up with positive? He's right. Why is it positive in this range? He's right. Something to do with the cactus dance. Okay, go back and look at this. What do you know? Is this even or odd function? Odd. It's odd. How do I know it's odd? The degree is odd. Now, once you know the degree, you're either going to go hands up, hands down, or they're going to go opposite ways, right? For those that are watching this, you're watching it played back, they're in opposite directions with the right side up and the left side down. How do I know that? Because the leading coefficient is positive, okay? So because I know that, I'm going to come back down here. Anything to the right is going to be going up. What's going to be happening down here? It's going down. Now here's the next thing. It's going down, so this is going to be negative values. Right? Oh, I'm sorry, this is going to be negative values. I said it and I wrote it wrong. Now here's the next thing. This is a degree 3. That means at most there's going to be 3 solutions. Some of those solutions may be real, some may be complex. You okay, Anthony? Okay. Some may be real, some may be complex. So we have 3 real solutions. We can see that. Why they're real? Because they have no eyes to them. They're actually we can plot them on the x-axis. So there are no multiplicities here other than single multiplicities. Why does that matter? What does a single multiplicity do? It just cuts straight through. A multiplicity of 1 cuts through. What would a multiplicity of 2 do? It would touch it, it would bounce back, right? That's not what's happening. Because we can see here, there's only a multiplicity of 1. There's not an extra x plus 4 where there'd be a multiplicity of 2. So this cuts through. What's happening up here then? This is positive. This range is positive. What's happening here? This is negative. And what's happening here? So if there's single multiplicities, every time the y values are simply changing signs. Every time. Now, is there another way that you could have done this if you didn't have that knowledge? Absolutely. You could have taken any value to the right of 5, like 6. You plug in 6, and if the output is positive, it represents everything over here as positive. You choose a number between negative or between 1.5 and 5, like 4, 3, or 2. You plug it in, it gets a negative value. Everything in here would have a negative y value. Thumbs up or thumbs down if you understand one of the 2 ways.